let's look at what the MNIST dataset actually is.
This video is brought to you by OppiPies Academy.
Okay, so now the MNIST dataset is basically a big dataset or a set of images which are handwritten digits. Okay, and next to those handwritten digits, you also pass in labels of those particular digits. Okay, so over here in the first row, we have zeros which are handwritten zeros, and then whenever you are passing this to a machine learning model, which we'll come back to shortly, then you also tell the model that this is an image of a zero. Okay, so whenever you are passing in any particular input, you also give the output value which should have been generated. Okay, so over here it is fairly easy for the human eye to also classify some basic digits over here, as immediately just by looking at these particular images we can tell that this is a particular digit 0 or 3, 4 or 8 or something of that sort. But for a computer, this is very hard, because whenever a computer looks at any particular image, it only sees a huge line of pixels, and then those pixels are arranged in a manner in which you can relate a particular image. But you can see the image, but making sense out of that particular image is very difficult for a computer directly. And that is when we have machine learning or artificial intelligence which comes into play. Okay, so now let's spend some time and understand what is the difference between a classical programming approach and a machine learning programming approach, and why a machine learning programming approach is most efficient to solve a particular problem like the MNIST dataset, which is further used to check the accuracy or to check how strong or how accurate is your model when looking at a particular set of images. So that is how we are going to also use the MNIST dataset to create a model which can train on the MNIST dataset on the Google Cloud Console, and then we'll look at the loss and also see some results. Okay, so over here, first of all, we have two red boxes over here, which is first of all the machine learning model, and then we have the classical programming model. Okay, so now first of all, whenever you have a particular set of input and output. So in this particular case, the images, the handwritten images or the handwritten images of the digits are our inputs, and the label of what these images actually correspond to is our output. So in the case of a machine learning model, we pass in the input and the output, as you can see over here. So we are passing in the training labels, training images, and also the labels. And the task of this particular machine learning model is to generate the rules for us. Okay, so it generates weights and biases, which are further the rules which when put into a neural network can give you an exact output. Okay, so let's look at a simpler version. Okay, so over here in India, we get voting rights when we are at the age of 18. Okay, so if you want to build a machine learning model which tells if you are capable to vote or not, then that is when you have to somewhere put in this particular rule which says that if age is greater than 18, then you can vote, and if age is less than 18, then you can't vote. Okay, but if we were to write a machine learning program, then we would pass in a set of parameters. Okay, so we would pass in the age and also a value yes or no if to that particular person can vote. So if we pass in 17 and say no, then that is when the machine learning model generates some particular set of rules. Then when we pass in 19 and we say yes, then there are more rules which is generated. And then slowly, by passing in hundreds and thousands of examples, the machine learning model slowly generates a good set of rules which you can then use to check if you are eligible to vote or not. So in this particular case, we have only passed in the age and the availability or the allowance to vote, and the machine learning model has given us the particular set of rules. So in this particular case, the rules which are generated are a little bit more complicated than a simple if statement which compares your age to 18. So in this particular case, the set of rules which are generated are weights and biases. So as we have looked in the neural network section, to define a particular neural network, you need all of the weights and the bias of each and every neuron. So once you have the weights and the biases, you can define a well-structured neural network. Okay, so in this particular case, the crux of the upper part of the diagram is that there is a machine learning model which takes in the input and the output and then generates the set of rules for us. So then we come up to the next part of the equation or the model, which is a classical programming model, and this is also required for a program to function properly. So now in the case of a classical programming model, we pass in the testing images. Okay, so we pass in some data set which is not in the initial data set which was used for training. Okay, so we pass some new samples into this particular classical programming model. Then we also take in the rules which were generated from the machine learning model above, which are the weights and the biases, and we feed these two things, which are the rules and the input, to the classical programming model. And then at the output stage you get a particular output label. Okay, so initially when you are looking at the process of training the model, you will only be cycling through the upper half of this particular cycle, where you will only be passing the training images and the labels and then checking the loss value. Then you will again run the entire program, and you will make sure that the loss value is reduced by implementing various optimizers like gradient descent or Adam optimizer, which we'll come back to shortly. But for now, for the process of training, all you have to do is to change the value of the rules. So change these particular rules so that the loss value or your error rate from the expected output which is provided over here is the minimum. Okay, so this completes the training part, and then comes the testing part where you pass in a particular image and then you also pass in the rules and check the output value. Okay, so whenever you are doing any Google search or you are using your phone for face unlock, you are only using this part of the cycle, which is the testing part. Okay, so that is pretty much it for the MNIST dataset. I also wanted to extend this particular lecture to also talk about the entire cycle of how a machine learning program actually works and what are the different processes involved. And yes, that is pretty much it about the MNIST dataset. And now from the next lecture onwards, I'll go behind the screen and we'll start programming a particular MNIST dataset classifier.